Can you prove this property of logarithms? We have a log of x to base b is equal to the log of x to the n to base b to the n. So here's what the property is saying. If the log of x to base b equals to some number L, and you take this base to the nth power, and whatever this value is to the nth power, it's still going to give you L. So this will also be L here. So let's look at an example. The log of 8 to base 2 is 3, because 8 is equal to 2 to the 3. That's by your definition of log. The log of 64 to base 4 is also equal to 3, because 4 to the third power is equal to 64. 64 is equal to 4 to the third power. The log of 512 to base 8, this is also equal to 3, because 512 does equal to 8 to the third power. So here we have properties of logs. So I'm going to put these just for you to read them. You can pause the video here. Properties of logarithms, and the conditions a, b, m, n are real numbers. Bases have to be positive. So we have all these conditions here. And of course these are the properties that you would use to solve logarithmic equations. Sometimes you get equations where you have different bases. You have to deal with that. Sometimes you use the change of base formula here. And of course you use the definition of log. So again, definition of log states that the log of x to base L, the log of x to base A rather, is equal to L, means that whatever this number is here, x, has to equal to whatever this base is taken to this power. So I just did something like that right now. So just remind you, I just write the log of 8. Log of 8 to base 2 does equal to 3, as I pointed out. Goes both ways, because 8 is equal to 2 to the third. That's your definition. This is the logarithmic form here on the left, and on the right we have the exponential. So you can go from log to exponential by taking this number equal to this base to this value here, 8 equal to 2 to the third. If you're given the exponential form here on the right, and go back over here, this is the base right here. That's going to go here in this position here. The exponent, that is your logarithm. That's going to go on the right. And of course the 8 will go here. So let's go to that's the example here. And let's go back over here to this one. So how can we show this? So what I'm going to do is I'm going to take this right here and say, okay, let's suppose the log of x to base b is equal to some number. We're going to call it L, because that answer is actually the logarithm. It's an exponent. So we have it this way. Now what we want to do is we want to show that the right side is also equal to L. So here what I can do is, okay, let's go to exponential form. So x equal to b to the L. That's just your definition. I just went over that. X equal b to the L. Now let's do this. Since I know those are equal by definition, I'm going to take each side to the nth power. So we have that. X to the n. We started off with x equal to b to the L. So since those numbers are equal, we take both sides to the same value, n. And then I'm going to rewrite this and say, okay, on the left side, that's just x to the n. And on the right side, I got a power to a power. That's the same thing as multiplying the exponents. So I'm going to multiply the exponents there. Powers of exponents, or roots of exponents. So I got L times that. And then this I can rewrite it as b to the n. I'll put it in parentheses. So here I got x to the n. Look at this part right here. X to the n is equal to b to the n taken to the L power. That's an exponential form. So let's change this to logarithmic form. So in the logarithmic form, I put the log here, and then I want to find the base that goes with this one. Well, since I have it in this form here, b to the n is taken to the L, so you can consider this b to the n as a base. So that would go here. That's your base, b to the n, for the log. And then the logarithm would be the exponent. And of course, in this case, I have two exponents, but I'm using this as the base. So the exponent for this base, b to the n, is L. This will be L over here. And what else is left? The only other number left here is this one here, x to the n. So I have then the log of x to the n to base b to the n is equal to L. But remember, here, log of x to base b is equal to L. So I can conclude then that this is equal to log base b of x. So what I've shown then is the log of x to the n to base b to the n does equal to log of x to base b. And that's actually the proof. So again, this is saying if you have anything like this and you want to change it somehow, some power, put a power here, put a power here, then the result is still going to give you the same. And you can use this when you're working or solving logarithmic equations, and maybe one or two of the log expressions in the equation have different bases. Well, you can use the change of base formula to get them the same. You also have this available to you. Thanks for watching. We'll see you next time.